Did you?
All right. I know Jakaya knows, Kristen knows, Cooper. Did you see the announcement about, I guess, the short and sweet of it is we strongly, our housemate, we believe, has COVID. So, I've set up another announcement that was sent out with contact information if you want to watch it, do this through Zoom. You know, we figure out what's going on.
So, would you know by tomorrow if we're gonna do Zoom, or are you still leaving it open to us to come in class?
I don't know yet. So I guess if some of you live 2 hours away, yeah. Yeah, I really don't know. I was at work this morning when I got a text from my wife. So.
Wait, are you saying someone from your family has COVID, or are you saying
No.
someone from in here?
No, not someone from here.
Oh, okay.
So the housemate, the one who's going through chemo,
Oh, okay, I understand.
she's the one who had it.
Okay.
Or her
I thought you
family
meant
has
someone
it.
in here.
Yeah, no. No, if it were someone in here, I would actually not be allowed to say that
Okay.
someone in here has COVID without direct permission from that person. And I probably should officially get permission from that person before I start spreading it, but unless you know the housemate, guess I narrowed it down to a woman, which. All right, so let's start out with any questions. Yes.
On master step 3,
Yep.
could you draw the ramp for me? I have a hard time visualizing what it's supposed to look like.
I believe it's this one starting here, it's gonna come flying off. So up until the end of the platform here, it's a one-dimensional problem. It's a chapter 2 type problem. And then once it gets into the air, it becomes projectile motion.
Well, what about the table? Because it says the bottom end of the ramp is on a table and 0.66 meters above the ground.
Table, ramp. Yes?
We just came from the STEM lab, and we just did the triangle.
Just did the triangle.
I'll show you. This is what we have. That's what the student was teaching us.
So for part A,
He just told us to use this equation.
okay, that,
So are we wrong?
no.
Oh, okay.
That's right.
Okay.
Because in chapter 2, because it starts at rest, so my initial velocity is 0 meters per second. It's gonna go 1.5 meters, I believe that's the length of the ramp, if I saw correctly there. And the first one is, how fast is it going?
0.66 meters.
It's 0.66 meters.
Oh, are you talking about the acceleration?
All right, so for the first, so I don't have it sitting in front of me. Let's. Thank you. 10 kilogram point mass, so you don't have to worry about the size of it. Top of a 1.5 meter long inclined frictionless ramp, so 1.5 meters. Makes 30-degree angle here. Bottom end of the ramp is on the table and is 0.66 meters above the ground, so this is 0.66 meters. It's released from rest, slides down the ramp, and I give an acceleration of 4.9 meters per second squared going down the ramp. And off the table into the air, okay. So the speed of the mass is at the end of the ramp. So for the first part, it's constant acceleration. Matter of fact, it's two constant acceleration problems. So for the first part, it's constant acceleration. So therefore, we have four cake formulas. And let's see if we can do it without looking at notes. What are the four cake formulas?
Displacement. Is initial velocity t or time plus 1/2 acceleration times squared.
All right, there's one.
Are you asking for a time independent equation?
I'm asking for just all four of them right now.
Oh, I had, V parentheses T equals V0 plus A times T.
You'll notice that this board will sometimes changes color too. It seems to be flipping back and forth between highlighter and pen. Yeah. Another one. Again, preferably without anyone looking at notes.
Those are the only two I have.
Displacement equals, it's final velocity plus initial velocity?
You said final velocity,
Plus initial velocity?
you said plus?
Yeah,
Okay.
over 2. And multiply it all by t.
That's just average velocity times time. And then the last one, so there's two displacement ones and then two V's.
Final velocity squared equals initial velocity squared.
Is it minus 2? Is it that?
Plus.
Is it acceleration times time times displacement?
Times displacement. And the multiplication is a dot product.
That's a S.
That's an S. Again, this assumes constant acceleration. So over here, I have constant acceleration from here to here, and then I have a different constant acceleration from here to here. When we get to chapter 4, I won't need to tell you that anymore. You'll be able to calculate that, but for now. So for the first part, the question is how fast is it going when it gets to here? Did I use the term how fast, I believe?
You said
What is the
acceleration.
speed of the mass at that?
Okay, what is the speed? So we're looking at this right here. I know initial velocity, I know acceleration, I know what the displacement's gonna be. We're trying to find final speed, which is the 4 equations.
So are you saying that we need the time independent equation?
Yep.
Because that's not what we used at the STEM. We used, V final squared equals, VI squared plus 2 times A times, delta X.
Yeah, there's no time in there.
I thought you said you wanted us to use a time independent.
That was time.
There was a miscommunication then.
Oh, okay. Okay.
No, wait, no, you do want to use the time independent one.
That one
It's
is.
the only one without time. in
The one you just said
equation.
out loud, that one's time.
Time independent, no time. Time is not involved.
Okay.
Yeah, you were saying it right. That's
Oh, okay, okay. So what I had was, VF squared equals 0 squared plus 2, times 4.9 times 1.5.
Yep.
And then I got 14.7, and then I did the square root, and then, we got 3.83 meters per second.
The process is right, I'm assuming you typed things into the calculator correctly. Okay, yeah.
Oh, okay. Oh, were you asking for the?
I think we're out of sync here.
Yeah.
So part A was just what's the speed, so you did it correctly.
Okay.
Shakaya?
Okay, so for the, B on part 1, and it was asking for like the positive or the negative. So did you just want us to put that in front of the number?
Yeah, so typically if I just say up is positive, and I have something that is falling at 3 meters per second. Let's make this positive J hat. Typically, if I'm writing up my velocity here, I need a magnitude and direction. It's going in the negative direction, so typically you put the negative up front. The direction, that's the direction right there. But typically you put the sign in front of the number.
Okay.
Some people will put the negative in front of the J hat, but if you do that, if you write 3 meters per second, some better than that. 3 meters per second, negative J hat, that's a subtraction problem. That's incorrectly written. If you want to do it that way, you need parentheses around that. So this and this mean the same thing.
Okay. Well, not what he wrote on the board, but that's just an example of what it would look like.
So was ours the Y? Is that?
And do we have to put the meters per second before the, J hat, or can we put it after?
You can put it after. Usually it's written right next to the number. So I guess we have one other way we can write it. We can write negative 3 J hat meters per second. Or 3 negative J hat meters per second. This is the traditional way, but these are not incorrect.
I'm sorry, I was writing something wrong. Where does this 3 come from?
I just, as an example.
Oh, so it doesn't have to do with this problem?
No,
Okay.
no.
So where I left off at, I guess that's why I'm a little confused, is, we found Y, but I guess I'm confused on what to do after that.
It's the I and J hat. The I hat and J hat, that's the example.
Right, so I think part B was basically what is the velocity? This found the speed, what's the velocity in horizontal and vertical components? I think I need to see this again. Nope. Oh, thank you. All right, so in I hat like I hat is horizontal and J hat is vertical. Thank you. And you need to define which is the positive direction. So the traditional approach, I hat, J hat, but you don't have to do that. You can have I hat going this way and J hat going down, or any combination thereof. Depends on what you want the signs in your final answer to be. But if you're setting it up like this, given the way I've set up the problem here, that velocity as it's coming off of it, well, it's going to the right, so it'll have a positive I hat component, and it's going down, so it'll have a negative J hat component. So the math problem here is whatever I'm breaking up is my hypotenuse, and I'm breaking up whatever that number was that you said before. I'll just make up a new number here. Let's say that it's going 4.5 meters per second at this point. This is not the right answer, this is just for example. So if this were 4.5 meters per second, my math problem is I'm breaking that up into components. That's 4.5. That's a 30-degree angle. And I'm trying to find my opposite side and my adjacent side. Capitalizing on the work that we did last week. This would be 4.5 times the sine of 30 degrees. And 4.5 times the cosine of 30 degrees. So, that's 2.25. That is not. 3.4. What is this?
One second. You said it's 4..
3.89.
3.89? Okay. So my velocity, if I'm breaking this up, given my convention right here, is 3.89 meters per second I hat minus 2.25 meters per second J hat. And then that sets up into the next problem, I think, with how far does it land from the bottom of the table, or how long is it in the air?
How long will the mass be in the air?
Okay. So to figure out how long is it gonna be in the air, for projectile motion problems, recognize there's an independence here between these two. There's a dependence, the dependence is time and the independence is everything else. It will be in the air horizontally for just as long as it's in the air vertically. But we'll treat them as two separate problems. I got displacement, initial velocity, final velocity, acceleration, and time. I've got my horizontal, I hat, and I got my vertical, J hat. I know it's going to, well, based upon the information here, again, given these numbers, which are not the correct numbers for that problem, but as an example, and since we're changing numbers, why don't we just make this 0.8 meters? So that 0.8 meters, is that vertical or horizontal displacement? All right, it is vertical. However, the correct answer is neither, given the way I worded my question. What is the vertical displacement? Given my convention over there. I will say the original intent of my question was for the answer to be vertical, but then I realized once I said the question, I realized that the vertical displacement is not 0.8 meters.
Is it negative 0.8 J?
Or negative 0.8 meters. We've already established it's vertical, J hat's right here, so it's understood J hat's already there. It's negative 0.8 meters. The fact that it's negative means that, since I said up was positive, that means it's going down. Or it ends up below where it started.
Dr. Farr? Are we considering this the new starting point to be as soon as it leaves the rim?
Yes, because my formulas here, which are incredibly useful, work as long as acceleration is constant. I have a constant acceleration here, and then I have a different constant acceleration here, so this is like a new problem. Yeah, I can't use those equations for the entire trip just because acceleration changes. What's my initial horizontal velocity?
Wasn't it 0? Because there's that rest?
For this part of the problem here.
Is it 4.5?
Not 4.5. That 4.5 is not horizontal.
3.89.
That's it. There. And the vertical?
Negative 2.25.
Alright, that's all the information we can pull from the calculations we've done already. But there is another piece of information that is not written down here, but is understood.
Acceleration as it goes down due to gravity,
What is the acceleration?
9.8 meters per second squared, or negative 9.8 meters.
Thank you. Negative 9.8 meters per second squared. And horizontally?
0.
And this is going to apply to chapters 4 and beyond. Typically, when you set up your coordinate system, like I had, Jay had, you want one of them to be parallel or anti-parallel to the acceleration. Our acceleration is vertical, so I really need a vertical one here, and then I pick another direction to be perpendicular to that. When we get to chapter 4, hopefully it'll become a lot more obvious about why you want to do that, but it does make the math considerably easier. So I'm changing my velocity only in the vertical direction. And so what I'm first going to find is time. This is the one thing that's going to be the same for both of them automatically. And so